get those links. Okay, welcome to this talk, and my name is Chris or Himing Fu, and this is a talk that is co-hosted both AI Camp as well as this little meetup group that I myself and a couple of other folks run called AI in Testing and Testing AI meetup group. So if you're interested in the stuff that we talk about, please feel free to sign up. Okay. So I'm assuming that all of you can hear me. If not, please let me know via the chat window. And also, if you have questions, there's a Q&A, so please feel free to ask questions there. Now, what I'll do is I'll answer questions immediately, but I'll pause at certain points to answer questions. Okay. So I'm hopeful that hopefully this talk will be under 45 minutes, and maybe have some time for some Q&A. Okay. So I'm now at the Medium article. Okay. So this talk is about building a deployable Jira classification engine using TensorFlow. So a little bit of history about how this little project came about. I'm a test manager at a company called Climate Corporation, and in the company, I was working on a little side project called Octopus. This is actually a name that I gave. It's not really an official title or anything. But the whole idea was to see if I could use some kind of machine learning algorithms to classify Jira bugs to teams. And we had, because we had all the labeled data already. So that was something that I could use to do some level of training. And then what happened was when I was enrolled in the deep neural network course organized by AI Camp, I wanted to see if I could apply a deep neural network to address this problem or something similar, right? But there were just two problems. So the project would require supervised learning, so you need labeled training data. I couldn't use the Octopus data because it was internal. And also the data set was very, very small. I think it was only like 200 to 300 rows. So that's not enough for training a deep neural network. So I need to find some kind of training data that was in the thousands. Then the second problem was the examples in the course were all image classification examples, but I wanted to do text classification, right? Now there's certain things that I wanted to achieve in this project as well. I wanted to train the model using GPUs. I've not done that before. Package the model into some deployable form, maybe using a Pickle or something similar. Package up the predictor into some kind of a post or REST API using Apache Flask, and then create a Docker image of the predictor package, and then create a CI pipeline to build the package and deploy onto the Docker registry. So the entire project can be found on GitLab. So this is the URL, and the URL is also on the chat. And the next thing was I did all the training on Google Colab because it is for those of you who are familiar with Jupyter Notebooks, Colab is Google's sort of notebook tool, and it has TensorFlow 2 built in, so you don't have to worry about installing TensorFlow 2. And also, if you select the runtime, you can actually select a GPU or TPU runtime. So those was interesting for me. Let me see, I think I saw a question. Let me take a look at it. Oh, Elam says, I see a black screen and no audio. Is it this, does everybody else have this problem? Or is just Elam that has this problem? Let's see. Okay. So Elam, if in the worst case, watch the recording. I think that should be fine. Okay, let's move on. Let's see, how do I... Okay, so with regards to the data, turns out that somebody actually had open sourced a data set of open source Jira tickets. And it doesn't, it's not just bug tickets, but also, like if you have tasks and other tickets, right? So it's all there. It's a few 100,000 Jira tickets in this PostgreSQL database. So you can find it, the link is over here. There's a Git repo, and if you want to have the whole data set, you can actually get it over here. And there's also a paper written on it. I have the reference, and if you go all the way down in the article, you'll find the reference to that paper as well. So what I did was I extracted it and put it onto a Postgres SQL database, and then what I did was and if for those of you who are interested, the data, right, is also on and so the data in CSV format is also available on the GitLab repo as well. So, but these are all bugs only. So there's a few CSV files. There's the Jira open data. So these are all the bugs that are there. And then there's a zookeeper, which I'll explain later, and the large set, which I will also explain later. Okay. So I chose the Zookeeper project because I wanted to do some model analysis on using traditional machine learning algorithms to see like how good or how bad it is. And so this is the SQL query I use, and it got about 400 rows. But I also extracted all bugs in the data set. This was about 200,000 rows. Notice that when I did a select, right, I chose status equals to close. Why? Because then you know that it's already labeled with the right priority. So we basically using the fields in the Jira ticket. And later you will see in particular is the title and description, okay, as the features. And then the priority, so like for example, major or minor or critical, those are the labels that we are classifying the tickets. So I needed them to be to have a label, so that's the reason why I chose closed. Okay, okay, so I was saying that I had I had chosen just to all the Jira tickets. That this was 200,000 rows, but then after doing some training, realized that I was really pushing Google Colab a little too hard, and basically it was having issues running out of memory, and so I chose a smaller data set, and this is the data set that I chose. So I chose the following projects within the data set. So Flex, JByte, RF, HBase, and so on. And so this was about 40K rows, so that was a lot more manageable. Okay, so after that, what I did was that Okay, so in the GitLab, right, you will see all these IPY and the these are uh, the the Google Colab notebooks. What I'll do is I will walk you through this now. Okay, so the first one is the exploratory. This one. So I have it in my Google Drive as well, but you know, for if you want to take a look at it, you have to go and upload into um, your G Drive. Okay, I'll just be walking through the notebooks. I will not be running them here because it might take too long. But you know, feel free to run them on your own. Okay. Okay, one thing to note about um, running anything on Google Colab, right, is that if you want to have you want to do a read CSV on G Drive, you need to do this over here. You need to import drive and stuff like that and mount the drive because otherwise you can't read from G Drive. Okay. Next are all basic Panda imports, and then you know these things like PD options. This is basically just so that you can just because some of my rows are extremely broad. There are a lot of columns, so you might not be able to see the whole thing. Now, all yeah, like I said previously, you can find the data over here, and this is something that I really explained. So what I did was I used the Zookeeper data set. And then standard data, exploratory data analysis, took a look at the data hit, and then took a look at data describe, which is not very useful because most of the data is categorical data, so it's not very useful, but pretty standard things to do. And then look at the data types because just to understand like what we're dealing with. Look at the columns, and then looked at title, description, and priority. So you can see there's title, description, and then the priority. So priority are things like blocker, major, minor, and so on and so forth. And so what I did was I merged the title and description into a column called features because that was what I was going to use for training. And then took a look at the what the shape was. Standard thing to do. So I have like 447 rows, and then as sort of like a baseline, I use the text block classifier. Basically, it's not doing any intelligence. So it just takes the whole block and then see you can use it for some kind of classification. And so did that, and then did your standard train test split. And this particular set of commands is basically just to mangle the data into a form that text block classifier can use, and then just run a simple naive Bayes classifier on it just to see the accuracy of it. Oh, that's not very good, but never mind. Okay, so that we know, right? Okay, something simple as a text block classifier we're looking at this kind of accuracy. And then I decided to see if I can improve that by removing a lot of junk in the text. So when remove all your your return, your tabs, and all that. And then also I went to remove things like emails and URLs to basically get. So what I was trying to do is to create some kind of a, for those of you who are familiar with natural language processing, is to create something like what they call TF-IDF, which is essentially something like a matrix of a number of instances of a particular word, and use that as the feature set, the feature set for training. But before I did that, what I did was, okay, after removing all the junk, does it improve the accuracy? No, it doesn't improve. Actually, then got worse. And so, I went through that process, like I mentioned. So the first thing I did was, before getting to the TF-IDF, was to create a count vectorizer. To use the count vectorizer to create something like a frequency matrix of all the words. And let me see if there's a link somewhere. Okay, so there are some, I think there's a link in my article that talks of the article that talks about how to, what this is supposed to do. And then what I did was to try to get some kind of tokenization so that we could get meaningful words to be used as features. And so long story short is I had to go and so this was basically just to look at what kind of words were extracted. And it's not very useful because you have like 0, 1 and all these numbers, right? So I had to try a few things, and in the end, I was able to get to something like this. So you have able, abort, AC, accept, and all that. And so, okay, this is good. But then these are only single words. What I wanted was at least to have bigrams. So bigrams are two-word combinations. And so that's what I did. I used, so you can see the n-gram range, 1 or 2. So then with that, I was able to get some word combinations that were quite useful, like excessive jar. What else is over here? Added zookeeper, and so on. Address, colon, and so on and so forth. So the number of columns now is about 1.6K. So that's still okay, not too bad. And the next thing I wanted to see was just to get a sense of how sparse it is. So I just did this to see how sparse it was. It wasn't very useful. So what I did was I went and used matplotlib to plot a graph just to see how sparse it is. Okay. I mean, I didn't really know whether this was good or bad, but I said, okay, fine. At least I know that it's a relatively sparse matrix. The next thing that I looked at was the distribution of the labels. So as you can see, major is like, has the largest number of data sets. Sorry, a large number of instances in the data set. And then you have blocker, and then you have minor, and so on. So it's basically unbalanced data. So there are a few approaches. One is just to cut it down so that you only have equal number. But because I didn't want to, I just wanted to see like, okay, how bad can it be? So I stopped there. I just said, okay, I'll use the whole data set and see what happens. Okay. The next notebook is the model analysis notebook. So this is the one where I actually use the standard machine learning algorithms to do some kind of classification, get a sense of like, okay, again, some kind of baseline before working on the deep neural network. So these are all standard again. And okay, so another nice thing about Google Colab is you can actually create like a table of contents. So you can just skip, and that is actually very useful when you actually want to skip. Okay, so standard setup, all the imports and all that. I'll skip these. And all these you've seen before in the previous notebook, basically removing junk. And then, okay, so I got the count vectorizer as like how I did previously. So I know that the words are in the, or at least the tokens what I was looking for. And then what I did was use a TF-IDF vectorizer to convert, to basically convert that into the feature matrix that I was looking at. So the difference between count vectorizer and a TF-IDF is that count vectorizer stores the actual counts of the words in the row or in the sentence. But TF-IDF, what they do is they will normalize it across the entire corpus, which means the entire data set. So if there are 500 instances of the word abort, right, and there are two instances of abort in your first row, then the number will be 2 over 500 for the TF-IDF matrix. So once you get that, then I did train test split, then took a look at between the training and the test data, what the label distribution looks like. As you can see, it's also unbalanced. And I was like, okay, let's just continue. And all the examples, to a large extent, I've been following from these two links. So there's a lot more explanation over there. So what I did next was, okay, just try the basic classification engines like the naive Bayes. This was like 38%, which is even worse. And if you can look at the what the precision and recall numbers are. I'm not going to go into like what precision and recall are, but long story short, precision is the number of true positive divided by the number of true positive plus false negative. So that means all those that are supposed to be predicted correctly, how many of those versus all the ones that are supposed to be predicted correctly. Then I look at logistic regression, same, wasn't that much better. SVM was slightly better. And then random forest was worse than the SVM. And then did some hyperparameter tuning, which didn't produce a whole lot of good result, but at least gave me some idea of like, what the what the baseline is. So the more interesting one, I think everybody wants to know is the what's the approach I went with for the deep neural network approach. So for that, I looked at, so there are a few approaches to apply deep neural network. One is to use an LSTM or your recurrent neural network. Another one is to use word embeddings like word to glove. Another one is to use some pre-trained networks like BERT. So for me, it was, well, during the course, we did a lot of CNNs or convolutional neural networks. So I was like, okay, can I use a convolutional neural network to solve this problem? And it turns out you can, but instead of using, in standard image classification, you use a 2D, you use 2D convolutions, right? But in text classification, you use a 1D convolution, or use a series of layers with 1D convolutions. And if you're interested, you can actually watch this YouTube video, and the person explains it. Another key idea is that you have this thing called embedding. So the high level idea of an embedding is that you just imagine words, okay? Because you're essentially dealing with a whole bunch of words, right? So just imagine these words are all mapped to some n-dimensional vector space. Then what you can do is you can talk about distance between words, right? And once you have this idea of distance, then you can say, okay, this word, based on the context, it should be closer to this other word. Say, for example, happy day, right? So happy and day should be, in this n-dimensional space, should be closer together because it is commonly seen together. And so the training becomes, how do we get these words to be closer to each other in the n-dimensional space? So that's the whole idea behind word embeddings. So and also the code for this, at least the base code, right, was taken from this particular course by the lazy programmer on binary text classification. So I had to convert it from binary text classification to n multi-category classification. So setup, there's some standard setup that needs to be done. And then, again, this is formatting so that it makes it easier for me to see. And then some common functions to plot the training, validation, accuracy graphs. And then, as usual, load and prepare data. So I have to do that. And then remove junk again. Remove junk. And then just take a look at the. So initially, I started with the Zookeeper dataset first, but then later I realized I actually needed a much larger dataset. So, so these are all stuff you've seen before. But this is where it's different from the standard machine learning. So you have to do some tokenization and then convert the text to sequences and so on and so forth. And you can find a lot of these examples in the lazy programmer course. Yes, and this part as well, basically getting getting them into word index and creating a dictionary. So you can see that after going through the data set, there's like 4,000 things. And then there's some part where you have to pad the data so that pad the rows so that they will all be the same number of rows. And so there was a very basic, as I mentioned before, this is from the lazy programming course. So I took it and tried it out. Wasn't very good. You look at it basically wasn't very, the accuracy was really bad. And because I was more comfortable with the sequential model, so I converted the sequential model and see, it's still not very good. And I realized, I need to actually put it to a multi-classification model. So that's what I did, converted it to that. Yeah, so that at least I was more familiar with it. And so, yeah, that's what I did. And okay, so, after doing that, after 5 epochs, it's like, okay, this looks a little bit more like what I'm used to seeing. And so then I also, to some extent, I was like, you know what, the data set is too small. So I used the large set data set. And again, I had to do all the data preparation and stuff like that. Let's see. Find the basic model. And yeah, and it's like, okay, yeah, after a while, you can see that it's overfitting. And it's like, is that, is there a way to have it not fit so much? And so what I did was, and you can see from over here on the left, I tried a lot of different approaches, trying different batch sizes, different number of epochs, and all that kind of stuff. And at the end of the day, I stopped at this point. This was the the neural network that I stopped at with early stopping, and this was the training, and it was only until it probably got once it reached about 5 epochs. That was the best it could do. It was about 52% accurate. So I stopped there because I also didn't have a whole lot of time. So it's okay, let's stop here. And then I worked on getting the actual training. And so you can see that production training. So in the production training, what I did was instead of doing a train type split, I used the entire data set to train. And then I packaged up into a predictor and I did some testing on that. Okay, so this is how it looked like, standard imports, and then functions, load and prepare data, and then training the model. This was the one that I stopped in the analysis. And this one stopped at about 14 epochs. And I got like, what's it? Training accuracy of like 63%. That's the validation accuracy. I think the best over here was like 54, 56, no, 65%. That was the best. 66 to 65%. And so that was the where I stopped. Then I saved the model into this format. Tensorflow has this ability to save the model, and then I tested. So you have test sentence, and got the result, and then you do a predict classes, and then you have to map the classes to the label, because otherwise you just get a number. So this was basically just to validate that okay, the prediction calls are working. Because the next thing I needed to do was to create app.py. Yes. And the app.py is essentially very similar to the last part of the code I showed you earlier. Except that you use Apache Flask to package that into an API. So you notice that these are all the data preparation that you saw in the previous two notebooks. And over here is essentially the function. So you get the data from the post payload, and then use it as to do the prediction, and then get the label. So these two lines over here are very similar to the test code that you saw previously. Okay, so now the one thing that I did and mentioned that I mentioned earlier that what I did was I wanted to package it up into a Docker container. And so that is what I did. And for those of you who are interested, there's a Docker file here that tells you how you how I package it up into a Docker container. So what another thing you need to do is to have a requirements.txt to list down all your dependencies, so you can take a look at the requirements.txt in the GitLab. And then basically what it does is just run the app.py. And then the GitLab YAML is essentially how to build it and then deploy it into the GitLab registry. So all these the environment variables that you see here, you can configure it in GitLab under under the settings. Okay, so settings, CI/CD is where you configure all these. Of course, I'm not going to show you what it is. It's some of my personal stuff. But what would be interesting is I'll demo the actual how you can run the predictor. So if you go to the quick start in the README, I have the command over here. Now, these, if you're running, if you're going to run the Docker container, run it on an Ubuntu-based OS. I tried it on Mac OS. It doesn't work. You need to run it on an Ubuntu-based. So over here, I've already set up the DigitalOcean VM. And what I do, and I've also installed Docker. So all these things you have to go and do it on your own. So what I'll do is I will run this. I'll run this container. So I've already done this before. So it's already pulled the image from the Docker registry. So it runs all this stuff. There's still some debug statements, and basically it's still setting up at this point in time. So it's converting sentences to it's getting ready, and it's already there. It's working, and it's listing on port 5000. It's not really. Okay, skip it there. You can figure it out. Okay. Okay. Now in Octopus, if you git clone Octopus, there will be a test which is essentially the curl command. So basically do a post with the data, title, description, and so on to your API endpoint. All you need to do. So it will run. Here is actually doing some work to figure out what to do. And if the demo got happy with me, there we go. So it basically classified the bug as a major. Okay. So that is the end of the demo, and that is pretty much it. Any questions? Everybody's good? No questions? I didn't see any questions. Okay. I see a question. How do you come up with the different networks in DNN experimentation? That's a good question. So, so what I was trying to do was, so there are a number of reference. I mean, if you don't have any experience, then I would encourage you to take the course because in the course, you actually get exposed to a number of different approaches. And one of the things that we also picked up in the course is, I think, I don't know which network it was, but the idea was that what you wanted to do was to first of all, there's the embedding layer, and then the convolutional layer, and or set of layers, and then you do things like max pooling and that kind of stuff. And so basically using to some extent, some level of intuition as well. Then after that, there could be a whole set of layers which are doing the classification. So one standard approach is to start with a larger sized tensor, and then gradually have it half or reduce. So those are the standard approaches. And then you have to worry about whether there's enough regularization in the network as well. So what I did was I used batch normalization, and I use standard regularization within the classification layers as well. But one of the things was initially it was like you look at the training graph, right? It's like very very quickly started overfitting. So one thing, one intuition is that you just increase the number of contributional layers to see if that will allow it to not overfit so quickly, to hopefully get to a better result. So that is the intuition. So it's to some extent it's a bit of trial and error, but also you can look at papers like what sort of network do they use, what was the intuition behind the networks that they use. So this is just a first step. I think, and just so I didn't really have a whole lot of time. If you notice, there was a lot of work that needed to be done to get the data and clean the data, and also I did some work on using the distribution ML to get some benchmarks as well. So definitely it's worth using things like word feedback or some other hyperparameter tuning approaches to see if you can improve the result. And also even like maybe doing some kind of a study on the features, as in the words that are more prominent. So I think there's this unsupervised learning approach, which I've not had the opportunity to try, which is called topic classification. I can't remember what it's called. But long story short, it's a bit like clustering, but you're trying to figure out like what sort of words belong together, so that you can actually possibly improve the result. I hope that answers the question. Any other questions? Okay, it's either you're overwhelmed or underwhelmed. Sure, go ahead, Bruce. Actually, Bruce, do you want to speak? I can unmute you.
Hello?
Yep.
Yeah, hi, Chris. Yeah, so I just noticed that in the
Yeah, I know what you mean. The validation accuracy was jumping around, right?
did that actually affect the production accuracy?
I do not know, actually. I think like a lot of folks who are taking the course for the first time, right? A lot of this is new, and I'm also learning it as I go along. But what I even in the example models for like image classification, like I've seen with here in the course, we also noticed that that was jumping up and down quite a fair bit. And whether that's good or not, I don't have enough experience in dealing with networks to say it is or it isn't. But yeah, I mean, I've seen that a fair bit as well. Sorry I couldn't answer it better.
No, that's fine. Yeah, just wondering what your experience was with that.
Right.
Okay, thanks.
Anybody else wants to ask a question? I'm happy to unmute you.